Hi everyone, this is Saad Aslam. I hope you are all doing well. So today we are going to discuss another LeetCode question, that is climbing stairs. So first let's discuss the problem statement of it. So it is a LeetCode 70 question. So you are climbing a staircase. It takes n steps to reach the top. Each time you will either climb one or two steps. In how many distinct ways can you climb at the top? So like there are different n steps you can take to reach the top, and there's a limitation that we can take only one or two steps, and we have to return the number of distinct ways we can reach the top. Okay, so this is quite obvious, and there are a couple of examples. Like example one is like if n, the number of steps is 2, so output is 2. So explanation is something like 1 plus 1 and 2 steps, and similarly example 2, like we have n is equals to 3 and the output is 3. So the explanation is like we can take 1 steps, or we can take 1 plus 2 steps, or we can take 2 plus 1 steps. So these are the different combinations we can make to reach the top. Okay, so let's discuss the approach of it in our whiteboard section. So before moving on, if you haven't subscribed to my channel, make sure to subscribe and all of the YouTube stuff. So now let's go to our whiteboard section. Okay, so here we are in our whiteboard section. So this is quite, you can say, a good example of dynamic programming. Like we can make use of our dynamic programming skills in this question, and this will be a very useful question for you to revise the concepts of dynamic programming. Just to give a brief intro of dynamic programming is like we memorize our you can say we memorize our solution so that we do not have to process the same thing again and again. Suppose like if we have traversed the first part, or we have encountered any we have included any sum, so we do not have to sum it again. We can memorize the solution so that we can process in a more optimal manner. So this is the brief introduction of dynamic programming. I have solved a couple of problems in previous videos too. So okay, so let's take a couple of examples to understand it more deeply. So suppose like we have n is equals to 2 in the example given, and this is our steps. Okay, so what is the limitation? Like we can take 1 or 2 steps. So what we can do is like we can take 1 plus 1 step. Okay, like we can take 1 to reach the top, or similarly say, or we can take 2 steps to reach the top. So how many ways there are? Like there are 1 plus 1 steps and 2. So there are 2 ways of reaching the top. Similarly, if n is equals to 3, okay, suppose we have 1, 2, 3. Okay, so how many ways there are? Like there are 1, 1, 1. This is the one combination. The other can be something like 1 and plus 2. Okay, like we can take 1 step and then 2, or we can first take 2 steps and then 1 step. So there are combination of like 1 plus 1, okay, 1 plus 2 and 2 plus 1. So these are the different combinations to reach the top. So we have to find an approach of it, how we can use it. So in dynamic programming, there are a couple of approaches we can use. Like we can use the top-down approach, or we can use the bottom-up approach. So we will go to the bottom-up approach. The reason is that like in bottom-up approach, our memorization of steps or memorization is quite easy as compared to our top-down approach. So let's understand how we can make use of our bottom approach here. Okay. Okay, suppose n is, you can say, let's see, n is suppose 5. Okay, so how we can use our bottom-up approach and using dynamic programming. In dynamic programming, we have to memorize our previous part so that we do not have to process it again. So let's make an array. We can use the like tree structure, or I am simply using the array structure here. So 1, 2, 2, 3, 4, okay, and here is 5. So first we have to find some base conditions, like if the number of steps is 0, suppose our number of step is 0, so how many ways we have? Like we have only one way, like we can do nothing. Okay, so there will be one distinct way of when step is 0, and when step is 1, like n is 1, so also we have only one option, like we can take one step. So this is the base condition, like for if a step is 0 or step is 1, we have only one way. So this is the base condition. We will start from the very bottom, like from the very bottom to up. So these are the two bottom cases. We will start from building up to the top. So for the top, step 0 and step 1, we have 1. Similar, but just we have to do is to find or calculate the sum of the previous two. Okay, so like for 2, we can take one step, or we can take the 2 steps. So we just have to take the previous 2. The sum of 2, like let me just change it. Okay. So the sum of these two is 2. Okay. And now let me just make it more. Okay, it is now looking like a 2. So the sum of the previous 2 is 2. Now for 3, we just have to calculate the sum of the previous 2. So for 3, the previous 2 is these. So the sum is like 1 plus 2. So the sum will be 3. Similarly for 4, we have to calculate the previous 2. So the 3 plus 2 will be 5. Okay. And for 5, we have to calculate these, the previous 2. So in this way, if you have noticed, like we do not have to calculate again and again. We are just using our previous calculation, and for using our previous calculation, we are calculating the steps for our other, you can say, upcoming steps. So in this way, we have used dynamic programming, we have used memorization, and simply we have returned our result. If you have noticed, like previously for 2, we, as our example, let me just take here. For if n is 2, the output will be 2, and if n is 3, the output will be 3. So here you can see for 2, the output is 2. For 3, the output is 3, and similarly we can continue for any n number of steps, like we can increase it to the n number of steps. Suppose we have n steps. Okay, suppose we have n steps. So what we just have to do is, like, we have to calculate the suppose our dp, suppose we call this array as dp. We just have to calculate for dp array, like the element in the array n minus 1 plus dp of n minus 2. So for any n number of steps, we just have to calculate these. Like when we if n is equals to 5, then we can make this array, and we will start from our base condition, like from these two, and we will continue building this array up to the nth step. Okay, so this is the approach of it, bottom-up approach. The time complexity of will be something like, you can say, order of n, like, because we are processing n number of steps here. So I hope you have understand the approach. This is a good question for you to practice dynamic programming. So now let's try to implement this in our implementation part. So let's move to that part. Okay, so here we are in our implementation part. We will first implement it using Java, and after that we will implement it using C++. So for that, we first we have to make a DP array. Okay, we can name it as you want. We are simply like DP. Int DP is equals to new. Okay, DP is equals to new int and n plus 1. Why we are incrementing it 1? Because if you had noticed in our array, if n is, suppose n was 5, there was an additional element of our base condition 0, so we have to initialize our array with n plus 1, so that we can add our extra base condition in that. Okay, so for that we have two base conditions, like dp of 0 is equals to 1 and dp of 1 is equals to 1. For the like 0 and 1 we have these base conditions. Now we are going to make a for loop, like suppose for int I is equals to 0, I is less than and equals to n, and I plus plus. So this will process from our for just I missed one point. We do not have to start from 0, we have to start from 2, because we have already assumed, like for the dp0 and dp1 our steps will be 1, so we have to start from our step 2. Okay, so that's why we are starting from the step 2. And for dpi, for like dpi will be in first, it will be dp of 2, and what we have to calculate, as we have discussed earlier, like we have to calculate dp I minus 1 and plus dp of I minus 2. So in that case, in our first iteration, if we discuss our first iteration, so first iteration will be dp of I minus 1, I minus 1 will be dp of 1, and dp of I minus 2 will be dp of 0. So we have already these values 1 plus 1, so dp of 2 will be 2, and it will carry on and continue to other steps as well. So when we have processed our dp array, we simply have to return our nth element, dp of n. Okay, the last element, like the result at the last step will be our result. So return dp of n. Okay, so that's for it. Now let's try to run this code. Oh, sorry, I just missed this. How can I miss this? So the code has run successfully. Now let's try to submit this. Okay, here you can see the code has been submitted successfully. The implementation is short, but the idea behind is, you need to understand the idea behind dynamic programming we have discussed in our whiteboard section. So now quickly implement this in C++2. This is almost similar, just a couple of tweaks we have to make. Okay, so here we need to initialize dp is equals to n plus 1. Okay, Okay, so here you can see the code has run successfully in C++2. Just we have to tweak our DP array initialization in C++, and now let's submit this to. Okay. So here you can see the code has been submitted successfully in C++2. So I hope you have understand this problem. If you have any queries, you can let me know in comments. If you have any suggestions, you can let me know in comments, and you can reach me out on LinkedIn as well. I have a complete playlist on these problem solving questions. Like, these questions are very important if you are preparing for any interview preparation or for any technical interviews, for any coding interviews. So I encourage you to watch these videos and try to practice this as much as possible. So see you in the next video. Bye bye.